It's Hugo Bowne-Anderson here for Outerbounds. Very excited for today's Fireside chat. Super happy to be here with Santiago Valdarrama. What's up, Santiago?
It's all good, man. Thanks for inviting me.
Absolutely. Thanks for joining. Everyone joining right now, please introduce yourself in the chat. Let us know where you're watching from, and what your interest is. Do you work in machine learning or AI? Are you a research scientist who's trying to start building more software and machine learning tools and that type of stuff? So let us know where you are as well. As I said, because I'm in Sydney, Australia, and Santiago, you're in Florida, right?
I'm in Florida, West Palm Beach, Florida. Yep.
Amazing, man. Amazing. A bit jealous, but we did have our first. It's been winter here. Winter in Australia is not like winter in many places. But we had one of our first hot days, so I was at the beach on the weekend, and it was action packed.
Cool.
And of course, this is like one of the weirdest time zone collaborations one could do because it's 8 a.m. here on Tuesday morning, and it's 6 p.m. there
6 p.m.
on
Yeah.
Monday.
6 p.m. here. Yeah.
Um,
It's just crazy. So you are
awesome.
living in the future right now.
We were just talking about how amazing it is that we can jump on a Zoom call and stream live to YouTube from being on opposite sides of the world, and people globally who are interested in these things can check it out. Look, we've already got people introducing themselves in the chat from Sydney, Australia. We've got someone from Santiago in Chile. So your namesake, which is a beautiful city. I once did a bus trip from Santiago over the Andes to Mendoza in Argentina. It was incredible. We've got Chicago, we've got Kuwait, Denver, Washington State, com-sci student from San Diego, Denver, Auckland, Seattle. So we've got a whole bunch of people. We don't have yet. I had one person tune in once who said they were from Antarctica. Well, they weren't from Antarctica, but they were watching from Antarctica. And I appreciated that because the bandwidth is expensive there. So just to let you all know, this Fireside Chat is brought to you by Outerbounds. And Outerbounds works on all types of productivity tools for data scientists, machine learning engineers, AI engineers. And Outerbounds can help you build ML and AI applications, including LLMs, and help you with all the infrastructural stuff. I love a lot of the work Outerbounds does, and I work with them full-time for many years. And I met them because they were working on a tool called Metaflow, which is still a big part of their value proposition, which is a productivity tool for data scientists that they built at Netflix and open sourced at Netflix. And I know, Santiago, that you've become more interested in Metaflow recently.
Yeah, I am. So actually, the class I teach, I've been teaching it so far, focusing on SageMaker. So that's AWS machine learning platform. I'm starting in November. All of the code walkthroughs, the entire class will be taught using Metaflow. Number one, it's open source. Number two, is super flexible. And the most important thing is very, very simple. Which is one of my knocks against SageMaker. Anything that you want to do takes just too long, too much code. With Metaflow, it's simple, it's clean, it's beautiful. So yeah, I'm going to be teaching the class using Metaflow.
Amazing. So if anyone's interested in checking that out, please do check out Santiago's class. I've also linked to the GitHub for Metaflow. Check it out. Give it a star if you're interested. We have so many people. There are people tuning in at 1 a.m. wherever they are as well. There is a question already, which I'm not going to ask you, Santiago, but I'm going to respond to it myself. The question is, ask Santiago why he doesn't always reply to comments on LinkedIn. I want to answer that for myself. LinkedIn can be a very intense place a lot of the time. And when you post a bunch and have a lot of people replying, it's actually not always easy to reply to everything. So I appreciate everyone's patience with me not replying to everything. I would need a full-time team of people replying to everything. And Santiago has a trillion X the engagement that I do. So I just wanted to make clear that it's not that we don't want to, right?
Yeah, no, it's and specifically on LinkedIn is the platform that I spent the least amount of time. So I try to answer more people on X, which is where I spend most of my time. So if you ask on X, you probably get an answer from me, especially if it's a good question, if it's a question that a lot of people will care about. On LinkedIn, it takes me it's much more work for me to focus there. So that's the reason.
Absolutely. So I've also just linked to our Fireside chat and event calendar at Outerbounds if people are interested in upcoming ones and that type of stuff. Please do ask questions in the chat, and I'll try to feed them in. We already have interesting questions about using generative AI locally with client data and that type of stuff, which is something I hope to get to. And I know it's something you're very interested in. So maybe we can start by thinking a bit more big picture. So you focus on the entire machine learning lifecycle in your course, but in the content you produce more generally and your work.
Yeah.
So Santiago, I'm wondering if you could walk us through the major stages and explain why understanding the full process is critical for ML engineers today.
Yeah, 100%. So one thing that you quickly learn from reading a book or watching a class is that machine learning is usually taught starting with a data set, and you are done as soon as you produce a model that can make good predictions. That's usually sort of like the life cycle that people focus a lot of time on. When you go and work for a company, you quickly realize that that is just maybe 1% of the work that needs to be done, right? Number one, the projects usually work way earlier than the point where you have a data set. Like you're literally presented with a problem and you have to go and determine what is the data that you need. And you have to go and figure out how you're going to capture that data, how you're going to clean that data, how you're going to prepare that data. All of that comes way before you have that data set. And the work ends way further after you have a model that makes predictions. You have to deploy that model. You have to monitor that model. You have to retrain that model. It's a continuous process that comes after that. So it's like, it's like when you're zooming in and you get any book there, the book is like a zoomed in version of what the life cycle is. I like in my class, because of my experience, I like to zoom out a little bit. And I like to cover the actual end-to-end process. I have many students that come here and they feel they have very good sort of like fundamentals. And it's surprising to them when they realize, oh, wow, we've been swimming in a pool, but this is actually an ocean that we have to focus on. So that's my approach there.
Amazing. And could you walk us through the major stages or the key things that people need to think about?
Right. So, usually you start with data collection, you start with data transformation, like cleaning the data, preparing it. Labeling is another big step. I think Andrew Karpathy famously said a long time ago that he was given a budget, I don't remember how much money, he would spend the entire budget just in labeling, just improving the labeling process. Super important. Obviously, you get the modeling phase, which is the one that everyone likes, just creating that machine learning model. You get evaluation stages. Evaluation is huge. It's not just testing a model with a test data set. It's actually determining how many different ways you need to use just to make sure that model works correctly. You get the deployment phase. You get the monitoring phase. You get the testing in production phase. All of those are different components that will make up the entire life cycle of the machine learning model.
Awesome. So you mentioned that labeling is incredibly important, and that Karpathy, of course, said famously that he'd spend almost his entire budget on it. I'm wondering in your mind, what is often the most overlooked phase, or one that people should focus on more but do not?
Good question. I think from the entire life cycle and going beyond labeling, the thing with labeling is, even though people don't spend a ton of time thinking about it, they quickly realize how important it is. But I think one of the most overlooked phase is monitoring models. So after you have a model in production, we get the sense like the work is already done, or the worst is behind, and it's not even close. Like the minute you put the model in production, the world will keep changing, and your model is going to start making bad predictions really quick. Like the degradation is going to be palpable. So monitoring the model, staying on top of it, understanding how that model is changing and what you need to do to keep it up to date is extremely important, and something that catches people by surprise because they're not expecting that that's going to be something that they have to do. I think that's one of the most overlooked areas in machine learning for sure.
Awesome. And I love that you mentioned monitoring, because I've actually enjoyed a bunch of your content on thinking through different types of drift. So I
Yeah.
wonder if you could say, I don't have, I haven't formulated the question quite properly, but the idea, of course, is that whatever your system is doing changes over time, right? The data coming in may
Yes.
be the distribution you thought it was coming from may not be representative of what's actually coming in next. So we get data
Yeah.
drift, model drift, concept drift, and we need to monitor these types of things. So maybe you can speak from a very practical perspective of how you've seen
Yeah.
this play out in an example or two.
Yeah, no, absolutely. So one particular example, just think of cell phones, right? So imagine that you have an application that expects images that were captured from cell phones, from users. Just take a picture of something and upload that application to your, upload those images to your model to make certain predictions. Over time, people will start upgrading their cell phones, and from 1 year to another, you are not going to see such a big jump. But with all of these cameras using different tech to bin pixels and to create high resolution images and whatnot, after a few years, you will definitely see a huge difference from the quality and the type or how the images look that were captured with those cell phones. So imagine a model that you trained, just to go to an extreme, imagine a model that you trained in the early 2000s with pictures from Nokia phones or BlackBerry's phones, right? And that model will be a disaster if you try with pictures from an iPhone from the last generation. Obviously, that's a very long span of time, but you can even see those changes happening year after year after year. So that's an example of drift, where the data that we're supplying to this model is changing from the data that we used to train that model. That's one example. COVID is another example. The warehouses planning using a machine learning model to plan for how much toilet paper they had to store overnight. All of a sudden, their models were making bad predictions just because of COVID, right? People wanted to buy more toilet paper. That's another example. That's a little bit of extreme, but again, it's just the world changing and the model not being able to make good predictions because now it's a different distribution out there. It's just the world is different. Yeah.
Those are wonderful examples. And I love the toilet paper example. I love the camera example. I love the toilet paper example as well, because there were actually two types of toilet paper. I don't know if you remember this, there are many, but there were toilet paper at home and toilet paper at work. And so offices which were empty were full of their type of toilet paper,
Yeah.
and we couldn't get it at home. Now, there was a joke that the supply chains were different and that even office toilet paper is actually, it doesn't come in the rolls, it comes in flat sheets a lot of the time, so you couldn't use it at home and that type of stuff. But these types of drift fundamentally super important. So this is the life cycle. I want to think more about deploying in production. So I'm wondering from an engineering and software perspective, and I want to frame this as a conversation. I think my background's in research science, and a lot of people think of this, as you said, as model building and that type of stuff, and not necessarily building robust, reliable, consistent software. So when we deploy machine learning models production, what type of failure modes do we see, and how can we avoid them?
Yeah, no, that's a great question. Well, the first thing that I like to think about is deploying a model. Like, the model is just a small component of a software solution, right? And people tend to think, or people tend to give responsibility to a model that doesn't necessarily lies with the model. So the way I like to think about it is the model is just going to be a small component, and you need to build everything around that model to facilitate what that model needs to do. So let me give you one example of a failure mode that you just asked, and how you could solve that using a smart workflow to make predictions. So one problem with machine learning models, let's imagine a classification model that's taken an image and wants to classify that image in multiple classes, is that models don't know what they don't know. And that's a fundamental difference with human beings. If I ask you something about rockets, you're going to say, I don't know anything about that. But if I ask a model that knows how to classify dogs and cats, and I show the model a picture of a giraffe, unfortunately, the model is just going to classify the picture of a giraffe as a dog or as a cat. It doesn't know that it shouldn't be making a prediction. So that's one of the fundamental problems when you're deploying these models because you're putting them out there. And you have to find a way to provide these models with the ability to understand that they should not be making a prediction whenever they are not equipped to make those decisions. So building components around the model that prevent that prediction from happening is extremely important. Now, just a quick idea of how you could do that. Imagine that you set a component in front of the model, you create a component that is going to take the input image and it's going to look that image in the database and it's going to ask the question, have I seen an image like this before? And if so, how good was the prediction that I made? And if the answer to that question is no, I haven't seen that image, or if the answer is yes, I've seen an image like that and I did not do good, then the model will refuse to make a prediction because it's much better for the model to say, I don't know, than to say, oh, that's a cat, right? Like what you want to avoid is just a mistake. So just creating a system that has that sort of like safeguard before the model even runs makes a huge difference. Remember, when you're using these models and depending for what you're using these models, you really need to trust the predictions that are coming out of the model, or your solution is not going to be feasible. You're not going to be able to deploy that if your predictions can be wrong, right? So those are things that we think about and we try to build in order just to increase trust in those predictions. Sorry, it's a mouthful. It's a lot of stuff. Like, hopefully that makes sense. Oh, I cannot hear you. You're muted.
There are lots of interesting points in there. I just want to say there are lots of questions about LLMs and generative AI. We will get to all of this stuff. Something that was interesting that you said in there, I think, is that if it can't classify, it should tell you it can't. It shouldn't make a certain prediction. And this is something that LLMs are generally horrible at. They will continually tell you a response that isn't correct. And I do want to get to that type of thing. Before that, though, I am interested if you could share, because people learn from negative results and failure so much. So I'm wondering if you could share from your own experience an example where deploying a model to production didn't go in as planned and what you learned there.
Let me try to think about, like, by the way, many times I've just made.
Oh, sure. Yeah.
I think, yeah. So I think one anecdote, it's not necessarily related to deploying a model, but it's related to failure to follow, to do what I say, right? So this stung a lot, right, when it happened, because it didn't happen when I was early in my career. It actually happened when I had a ton of experience. So I'm working for this company and I built a model that training that model took about 20 hours. And everything was great and everyone was happy, but we wanted to take the time down from 20 hours down to something more manageable. And I was using at the time, or at least I thought that I was using at the time, an instance computer with 4 GPUs. And it was taking 20 hours. So, I'm sort of like digging into that and saying, okay, what do I have to do? Do I have to bring more computers? Is it going to be less expensive? And then it hit me for a few weeks. Yes, I've been using a computer with 4 GPUs, but my code was only utilizing a single GPU. So yes, the model is taking 20 hours to train because I'm using a single GPU and wasting electricity with another 3 GPUs running. This is a problem that would have been caught in a second if I was monitoring operational metrics about my model. Like literally during the training process, I'm looking at GPU utilization. I would have seen that it was only 25%. Just because I didn't follow through, just because I didn't do what I tell people to do, I spent a lot of money because these GPUs are really expensive for weeks, and I was not taking advantage of them. So imagine me going back to the person who was responsible and saying, I have good news and bad news. The good news is that I fixed it, and now it's taking, it's much faster. The bad news is that I've been spending a ton of money throughout. So yeah, it's stuff that happens.
Yeah, absolutely. And to that point, hopefully we'll get to talk about local models at some point. And I think a lot of people don't know that even a lot of MacBook Pros have several GPUs these days, and you can leverage all of that
they do.
locally as well. I do want to drill down a bit more into the software aspects of machine learning engineering. I just wonder what type of things from software people need to start thinking about. So one example is, we've seen the rise of continuous integration, continuous deployment, CI/CD pipelines in machine learning. It's not obvious to me that this is always the best paradigm to focus on, but this is one example of something from software that has been brought into ML at large in some sense. So do you think CI/CD is incredibly important? What other things from software should machine learning?
It is. It's funny because it looks like in 2023, 2024, the machine learning community is sort of like rediscovering practices that we've had in the software community for years and years and years, right? So it's sort of like funny to me. One thing that I should say that I consider very, very important is, so number one, you do not need to become a software engineer in order to be effective. But if you do have knowledge about software engineering, then the work becomes extremely easy. You're much more effective because you can pair your knowledge in models and machine learning and whatnot with software, and that's just super powerful. Regarding to your question about CI/CD, that's exactly something that I teach in my class: how to build pipelines, which just it's like a workflow of steps in order to automate the process of training models, of deploying models, of monitoring models. That's the idea. When you build these automated pipelines, the ability for you, number one, to do things fast, it increases. To do things correctly, it increases. You make so fewer mistakes because you have an automated process. You make small changes. You run your process, and every single step is going to run in the order that it needs to run. Nobody's going to forget anything. You remove the human from the middle. That is extremely, extremely important to do. So absolutely, those CI/CDs. In the case CI/CD is a little bit more complex, but you get the idea. This automation, these pipelines are extremely important to build machine learning models that run in production. Yes.
Really appreciate your insight there. So now I would like to move to talk about the relationship and differences between traditional machine learning and AI, generative AI, these types of things. I suppose, firstly, I'd like your thoughts on the fact that even in this chat now, and of course on LinkedIn and Twitter, that a huge number of questions, a huge number of the cultural consciousness and mindshare is taken by generative AI, and yet 99.9% of the value delivered by AI and ML, I just pluck that number out. But it's the vast amount of value is the vast amount of value is still generated by regressions, random forests, and boosted trees, and then deep learning, right? But not necessarily in the generative sense. There's a huge 100%. Mismatch there. So what are your thoughts as an educator?
So Gen AI is just exciting. It's the new thing. It's the magic, right? And the attention goes there. But as soon as you go to a company, you're going to realize that it's the boring stuff, not what people are using to make money, right? Not only because it's well known, well studied, and there are a ton of people with experience building it, but it's because it's more dependable. Like, we know how to build systems that work using that old tech. We do not know how to build systems that work using the new tech, right? The new tech is at a stage right now, which I call it makes for great demos. And most of what you see out there is pretty impressive, huge demos, beautiful demos, but they're demos. And there is a huge gap from a demo to a running solution, okay? Huge gap. Now, I'm not saying that LLMs are useless right now. There are applications of LLMs that are extremely beneficial for humanity, and they're good and we can use them. What I'm trying to communicate is that many applications of LLMs, even though you see them in a demo and they look good, they're not ready for production yet. Remember, companies are out there just to make money. That's what they want. So they don't care if you're using an LLM. or you're using a set of rules. My recommendation to people, what I've seen over the years that work best, is that you start very, very simple, usually set of rules, and then you, as complexity comes in, you get into machine learning, you start adding complexity to those models. Many of the use cases that companies want to solve, you cannot solve with LLMs. You cannot just make predictions about sales of your company with an LLM. It's just not good for that. Like you get all of these people getting Gen AI and trying to fit it, like, can we use this to solve this problem? And we're just not there. So again, not saying it's useless. I think all of this attention is going to turn into more people discovering things and improving LLMs, and they will become more useful. But yeah, just be careful with that. Don't think for a second that LLMs just took over the world. They haven't. They're not there yet. Yeah.
Let me ask you though. So I agree with everything you said, but a provocation is, it seems like LLMs have some sort of power in helping us with traditional ML, either through in-context learning, by you give it examples and counterexamples, and it can start to build classifiers for you, or, and this is something that I'm personally very interested in. Bit more context about me. My background's in scientific research, so I've been helping. Part of my job is to help scientists build software. Now with LLMs, I think there's a huge opportunity for software engineers to build machine learning and AI now due to coding assistance. So I'm wondering if these examples of in-context learning, then the ability of non-ML people to do ML, whether this opens the space for more traditional machine learning to be done.
Yeah, I mean, I use LLMs every day. I use Cursor. That's my IDE, the tool that I use to write code with Claude Sonnet 3.5. I think it's amazing. I'm much faster thanks to it. I don't know how fast I am. I don't know. I've tried to predict before, maybe 30%, 40% more productive. Maybe. And I think those tools, like you said, will help people that don't have experience sort of like step up their game, right? Sort of like take over certain areas that was impossible for them before. I think there are still fundamental limitations with the code these LLMs produce, how deep they can get into that we're not there yet. Like, I do not believe that all of a sudden by the end of 2024, these LLMs will be doing developers' jobs. I don't believe in that. I haven't seen any proof that that is the case. All of the code that I've seen personally, that I've seen from these LLMs, all of that code has to be fixed. I have to babysit them. So they are tools that the more experience I have, the more effective these tools are. I don't know if you get the idea. Like, they're good. The LLMs are good to a point. And the better the person who's driving the LLM is, the more they're going to be able to get out of the LLM. It's like a car. Doesn't matter how fast that car goes. The driver is going to play an oversized role in that car winning a race. And if the driver is not good, it doesn't matter the engine of the car is not going to get to the end point. I think we're going to see more of that, at least until we find new breakthroughs that we don't know whether we're going to find them or not. LLMs are not just going to magically jump the hurdles that they have in front of them. It's not about more GPU. It's not about more data. It's about breakthroughs. It's about a different architecture. It's a different way of building these systems. And we don't know what those ways are. We're trying, but we haven't found those answers yet. So until that happens, I think these are going to be great aids to what we do. Great help, tools for what we do. Hopefully that makes sense.
It makes perfect sense. I'm wondering, in terms of avenues for research and exploration in industry, as well as basic research, what you think the most fruitful paths will be, and where we can look to deliver the most value.
Yeah, I mean, I'm not a researcher, but I can tell you that I see LLMs maybe as a component of a bigger system. Like, they are going to be sort of like the language component of a much more complex system that is going to use LLMs to do certain things. I even think they're going to be a small component. Right now, some people look at LLMs as the end-all be-all of artificial general intelligence. I don't think that's going to be the case. I think they're going to be a small component of those bigger systems. A lot of people are also focused on what they call AGI, whatever that means, artificial general intelligence. They want to create this system that is going to be capable of doing and solving all of the problems, right? I don't think we're remotely close to that. I think we're closer to a future where we're going to have many different specialized superhuman models. And what I mean by that is maybe we can build systems that are very good at summarization, are perfect, like superhuman, not perfect, but superhuman at summarization. Maybe we're even there. Or superhuman at writing Python code. Or maybe even superhuman at writing Python code for machine learning engineers, right? So smaller systems that are specialized and they achieve superhuman abilities on that specialization, that narrow niche. I think we're closer to that future than to a future where we have this almighty machine that can do everything and anything. So yeah, I'm not quite sure how we're gonna get there. I'm just paying attention. I hope we get there sometime. But yeah, we'll see.
Awesome. I love your points about AGI as well. I personally do think AGI is a huge red herring. I don't even think intelligence is necessarily well defined. I think there are lots of different ways to think about intelligence. I think a lot of humans I know, myself included, aren't generally intelligent most of the time as well. I also think it's like some weird God complex that we have as a civilization. Like, can we create something which and it's like, why don't we solve some of the real problems we have? And in all honesty, text classification and summarization, so we'll get to this, but if you're a freelancer or entrepreneur using LLMs as a productivity tool, you will be way ahead of the curve currently. I think than a lot of people. I am interested in kind of how different some of these things are from what we've had previously. So one take is that RAG, for example, isn't that different to recommender systems, right? So RAG is Rexis. I mean, there's a generative component to it, but essentially we're doing quite similar things there. So I'm wondering your take on a lot of the things we're doing are kind of old methods in disguise with a generative flavor.
Yeah, for sure. I mean, that's not sure what else to say other than what you just explained, right? A lot of things is sort of like so is new again. And things that we had all of these systems and we know how to build it. Like, for example, if you look into a RAG application, like a professional RAG application for production use case, and you start looking into the components that you have to build. A bunch of those components, we've been using those components and we know them well from other systems that we built in the past without a RAG. So for example, you have a cache component as part of a RAG application. Why do you need a cache component? Well, because you have to reduce the number of tokens that you generate. So maybe you cache certain requests that are similar from previous requests, so you don't have to regenerate those answers for all of the users. So, there are so many different components, evaluation components, and how you evaluate. We're using a bunch of techniques that we've been using for years and years and years. We're just adding the Gen AI flavor here, maybe an LLM here. Vector databases is sure. A lot of people are putting a lot of emphasis in those, but we've been using databases for the longest time. We've been using embeddings, the concept of embeddings, for years and years. Like, you think about embeddings, we've been using autoencoders to do things like anomaly detection for many years. And the idea of an autoencoder is very similar to the idea of generating embeddings, which are one of the fundamental blocks of LLMs and whatnot. So anyway, there are a lot of components here that are old that we're just reusing here with the flavor of Gen AI. Yeah.
Totally. And I do think it's really interesting to think through what's old and what's new. So I'm in terms of what's new, I'm interested in how you see skill sets changing. And one example that I'll give is that to build machine learning software, you used to have to be able to train models. Whereas now, and if you're doing deep learning, backprop, right? Whereas now, I think one fundamental difference is that you can ping APIs or like download transformers or whatever it is, right? So you actually, I don't think you necessarily need to be super proficient at all the math and training that you used to be. But I'm interested in your thoughts on that and other aspects of skill sets that have changed.
Yeah, and even before, this is not because of LLM. So when I started machine learning, every time you wanted to build a neural network, you had to define the training loop. You have to implement backpropagation from scratch. That was the years before TensorFlow and PyTorch. By the way, TensorFlow is not that old. It's from 2015. So it's not even 10 years. Before TensorFlow, we just had, it's just wacky the way you had to build neural networks. So knowing the math behind backpropagation and how to do a derivatives, right? And what gradient means and all of that stuff. Yeah, that was pretty important. That was critical. Without it, you couldn't build a neural network. But then these frameworks came along, and obviously we're just moving up one layer of abstraction, and now you're using these frameworks. And no, you don't necessarily need to know how backpropagation works. Maybe you have an idea of how it works, but you don't have to implement it by hand anymore. You don't need to understand how to create a derivative anymore. And I remember when deep learning came about, and we started pre-training these huge ResNets. We pre-trained these ResNets on ImageNet, for example. So we have just a big neural network that knows everything about multiple images, millions and millions of images. And training or adapting one of these networks to a specific use case was very, very simple in comparison with what we had to do before we understood how transfer learning works. Same thing that's happening right now with vision transformers. You can download a vision transformer for the internet that is already very, very good at classifying a bunch of different objects. You don't know where that came from. You don't care. You don't have to pre-train that vision transformer anymore. You just take advantage of it. So as time goes by and as we create new tools and new ideas, we're just moving, one layer of abstraction at a time. That will continue happening. It makes me a little bit sad that some people try to sort of like gate newcomers into the field by saying, no, if you really want to get into this AI thing, you have to know linear algebra. Well, yeah, you have to know linear algebra, just like you have to know, philosophy. It's good, but it's not an impediment anymore. Because what you really need to start from is start with just building with the tools that you have today. And if you need to, dig a little bit deeper. But I personally, it's like asking a developer that for you to understand how to write code in Python, you have to understand how the memory system, the RAM system of a computer works. No, you don't have to do that anymore. So we're just moving up that chain.
Yeah, absolutely. And I like the example about linear algebra. I've always used the analogy of the car and the internal combustion engine, right? So for me to drive a car, I don't need to know the ins and outs of internal combustion engine. If I'm a race car driver or a mechanic, these types of things, maybe I need to know a bit more, right? With respect to all the skills and fun stuff we can do with generative AI now, and we've had a bunch of questions about this in the chat, but so we can ping APIs, we can chat with LLMs. Then suddenly you start learning about tokens and system prompts and latency and memory, right? And then perhaps you start learning there are things called prompt engineering and RAG and fine tuning. So I'm just wondering, what some sort of learning path looks like for you. How would you encourage people who maybe know some science, machine learning, that type of stuff, to approach learning more about the generative AI space?
Yeah, this is a question that's funny to me, because a lot of people that believe in LLMs, right? They say, don't learn to program, because LLMs will take care of it, right? That's usually something that you say. Even some smart people in the industry have said that, right? Like in 5 years, we're not going to have developers. But if you look right now, what are the skills today that will allow you to take advantage of the field? That's software development. Like if you go and learn the math, you're not going to be good at building generative applications. There is no direct connection there. Like if you really want to learn something today to take advantage of all of this good stuff that's coming out, you need to be able to call APIs, to load classes and write code and put together all of these components in software. So it's sort of like, it's funny to me that on one side, some people are saying, don't learn how to do this. And on the other side, well, but to do everything that you need, you actually need to know how to write code. So what I recommend people is, if you're just starting out, if you don't know anything else, you gotta get good at writing code. That's it. It's just using these APIs is writing code. Building systems, I promise you, calling the API, the LLM API is 1%. The other 99% is managing exceptions and dealing with when the API is down, what's gonna happen and how do you present that answer to the user. Like there is a lot of plumbing that has to be written by somebody. Even if an LLM is writing 50% of it, you have to sort of like adjust that 50% to make it 100%, right? You have to review what the LLM is writing. So that knowledge is fundamental. So just go and write code, start experimenting, start working on different examples, and you're going to start building your career from that point on. That's just in the Gen AI area, obviously. That's not going to help you like build hardcore, I don't know, XGBoost models for financial information. That's sort of like a different field. But for Gen AI right now, focus on learning how to code and move from that point on.
Absolutely. And I do, there are some a lot of interesting comments. Natasha has written, at my work, it's frustrating to communicate with people who think they know AI ML, but have no basic knowledge. They don't know what they're talking about. I just want to say, Natasha, I feel your pain. I do think part of the challenge is we're all at different places with respect to a knowledge gap and skills gap. I do want to share my screen for 1 second to show a slide, but also I've discovered a new feature on my laptop which allows me to, can you see my face in my screen now?
Yeah, I can see it. Yeah.
I just wanted to do that. And I can also pop out when I get excited. So
there we go. That's pretty cool.
But this is actually a newsletter I put out yesterday. And I had a slide where I've been thinking about, this is inspired by a friend of mine, Alan Nicol at Raza actually, but how a lot of people tend to be at different points in the hype cycle, right? So a lot of execs are at the top being like, we need AI. A lot of devs are currently at the bottom. They're like, OMG, where's my scikit-learn lolsob? Like, I just want to use that, my traditional ML now. And many data leaders are in the middle. They're like, are we adding value or are we just adding more noise? So I'm wondering your reflections on the different places we are in the hype cycle and the knowledge gap that we have currently, Santiago.
100%. I think most people that I talk to, they are very close to the bottom of that line. A lot of companies that are, again, these are just people that have the opportunity to take a peek into what they're building. They're either in the very exciting, we can just solve every problem that we have, or they are at the very bottom, we have not gotten this stuff to work. Like, again, the demos were great, but there is still a lot of components that are missing, a lot of trust that we cannot just put on these systems. I think we're at that point there. I think it's just a matter of time. We have to build. It's not about just the models getting better. It's about everything that goes around these models that needs to become better for us to be able to build systems. Again, LLMs they're going to hallucinate, and that's it. It's just the way it is. How we can handle those, how we can prevent them from making mistakes, and those mistakes sort of like destroying our system, those are the things that we have to work with or around and wait for engineering to catch up with these LLMs. Like, what are the safeguards that we need to build? If there is an exception here, how do we know that this question we should not send to this LLM? Or how do we have multiple LLMs working together and build some sort of like gating system that decides which LLM to call depending on the problem that the user has. Like there are multiple techniques that we could use. We need to let this stuff to catch up with the LLMs for them to become more useful. I think we're not there yet.
I appreciate that. I do want to now start doing some more future thinking with respect to skill sets. I'm just wondering, as we look towards the future, what skills do you think will be most critical for, I say ML engineers, but really, I mean, just generally people building ML applications powered by data, whatever that means, right? So what skills will be most critical for these types of people to develop software in an AI-driven world?
Yeah, I mean, again, like I said, coding for me is going to be fundamental. Even though LLMs are going to get really good at coding, that doesn't mean that LLMs are going to be able to replace you. You still, I believe that we're still going to need coding skills in order to read the content that LLMs create, in order to write some code ourselves. So I need coding is number one. Number two is anything that's related with system design, architecture of systems. Those components, by the way, LLMs are not fulfilling that right now. They're not writing those. They do not know how to design good systems today, right? So when I say like building a system is precisely what I've been talking about. Like, okay, here is my model, or here is the core of my system, the engine of my system. But in order for that system to be helpful, I need safeguards, I need the cache, I need the database, I need replication, I need backups, I need the ability to if it fails, I need to be able to recover from that. So all of those pieces, somebody has to create and put them together in order to create systems that work at scale, that work reliably. LLMs are not building those right now. So a system designer will have to do that. The developer will have to do that. An architect will have to do that. All of those skills are really, really, really important for the future. When these LLMs get better, we're still going to need these people. So I think that's going to be an area that I would recommend people definitely to look into.
Awesome. So we've talked around this a bit, but we have a great question, which we've answered a bit of, but I want to state this explicitly. The question is from Harold Schrantz, and the question is, why are LLMs useful at all?
Why are they useful at all?
Yeah.
I can tell you how they're useful to me right now. So yeah, one example of LLMs being useful. I'm stuck on how to present one idea. And I asked the LLM, these are my raw thoughts. Can you give me sort of like 10 different ways of expressing this idea? That doesn't mean that I use an LLM to write the content that I write. That means that the LLM is an immediate unblocker for me. What would take me maybe have an hour to come up with, now I can do it in just 2 minutes, right? So that's just one way for writing. To help me, hey, this is a sentence this is an idea. I want to simplify this idea. How can I say it in a different way? It's a little bit simpler. The LLM will give me ideas that otherwise I wouldn't have. So that's one way. Another way is for writing code, right? It's just give you an example that I use all the time. I have a code file that's doing something, and I ask the LLM to explain to me what are the corner cases that I should be focusing on. Like, what are potentially, how is this code going to fail? And the LLM is going to give me three corner cases that my code is failing to capture. So, hey, you're not checking for this value to be none, or if this value is out of range, here is just going to raise an exception. Is that something that I can come up with? Yeah, for sure. But I will have to analyze the code. I will have to think through all of that. And now an LLM can give it to me just in seconds, right? The LLM can even write test cases to cover those corner cases for me. Now I'm going to wrap that code, I'm going to analyze the code. I'm going to make sure I like the code. I'm going to make changes to the code. But the foundation of that code, the initial, the lines are going to come from an LLM. They're extremely helpful for that. So those are just 2 use cases that I use them personally. For companies, the idea of RAG applications is extremely helpful as well. Many companies have these chat systems, or they have these sort of like burst response from a chat window where people ask questions, and that information is maybe in an FAQ in a different page that's answered somewhere, and the chat system can immediately answer that question for the user, and you save a ton of time from real people, attending that chat. So just you go and ask a question, and your RAG system will answer that question immediately. And if it doesn't know the answer, or if it's something that it doesn't have any information of, can just say, just wait a second, let's wait for an agent to just take your question here. So it will sort of like defer to a real human. But that initial answer can come from basically from a system that's powered by an LLM. So extremely useful in that regard as well. Yeah.
Fantastic. So in terms, we talked about skills. I actually really don't want to have tool-focused conversations, but I think in a space where people need to get started, it's important to kind of suggest a few things. And I think I'm wondering with the rapid evolution of tools, what tools or frameworks do you think people should play around with in the next year or so?
Yeah, I mean, I happen to have a book right here. So this is a book. This is Gen AI with LangChain. So LangChain is a tool that I like a lot. A lot of people have some gripe with LangChain. They like it, they dislike it, doesn't matter. Just a great framework that is going to abstract a lot of the complexity of dealing with different models, with different components that you need to connect to different models to create agents and whatnot. LangChain is a great tool. I mean, Llama Index is another great tool as well. So those would be tools that I will sort of like spend time on if you want to build Gen AI applications. As we come up with new things related to LLMs, these tools will, be updated so you can start building systems. You can keep building systems with these tools without having to dig too deep into the complexities of different APIs and whatnot. So that would be my main recommendation. And that's assuming that what you care about is just building applications that take care of, like, use an LLM. If you want to get into the how do I build LLMs, now that's a different story. Now I would suggest, or you will require a little bit more fundamentals background, a little bit more math, a little bit more, well, I need to understand fine tuning, I need to understand training, I need to understand backprop, I need to understand how these models, how can you create one of these models from scratch? That would be a little bit deeper, but just to build applications, just learn one of these frameworks, LangChain or Llama Index, and start building. That's it.
Awesome. I did want to just wrap up by thinking a bit about freelancing, and the fact that, a lot of people work in companies. You freelance in the ML space, and you've done that extensively. So for people doing it, I'm wondering if you could give us some insight on what you think it takes to succeed as a freelancer in the field, especially compared to working full-time somewhere.
Yeah. So as a freelancer, so keep in mind, specifically for machine learning, you're going to be, usually, in my experience, you're going to be thrown as part of a team. So building a system takes more than one person. And that's usually what happens, right? Especially if it's any system that's a little bit big. So when you're freelancing, they're hiring you to be part of a team. So obviously, working with a team and understanding what is your role and how you're going to help that team succeed is a huge part of the job. Even though we usually don't talk about that, we always focused on the skills part. So think about that. Also, you're going to be very successful as a freelancer the more from the end-to-end life cycle that you can cover. Like the more pieces you can touch, the better you're usually going to be. Like when you're thinking about a T-shape engineer, they call it like that. Going broader, it's a little bit better when you're freelancing as a single person than just being super specialized. At least in my experience, it's harder to find very hyper-specialized jobs as a freelancer. I don't know. What I think a big part of it is getting the job in the first place. That's one of the hardest things that I would say. Like getting that interview is a lot of competition, obviously. Getting noticed and getting that interview as a freelancer is a little bit tricky. But yeah, I don't know. It's just a huge field there. But yeah, I mean, you can do it. You can go on freelance and do it for years and be very successful at it. Yeah.
I love that you mentioned getting the work. as well, because
Yeah.
I do think being a freelancer involves so many parts of and the business development
Mhm.
stuff. I've actually got some friends who
Yeah.
are freelancers who've recently started taking sales training, right? Because they
Yeah.
realize that that's a gap in
It
what
is.
they're
Yeah.
doing. So it does really force you to confront yourself and your entire skill set and where
It
your
is.
gaps are. It's a
Yeah.
pretty wild self discover. I don't want to get too woo woo, but it is like you get a lot of self discovery when you start trying to build
Yeah.
your own freelancing business.
I mean, I usually recommend people. I used to do this thing that I think it was very successful, but people usually don't think like that. So I recommend people to do this. I call it day one approach. The idea with day one approach is when you're applying to a job, this also applies outside freelancing, but when you're applying to a job, especially in one of these freelancing platforms, there are over 100 people applying to the same job. So getting noticed, getting that phone call is very challenging. So the day one approach is one advantage that you have on your freelancing, as usually you get the description of the job that you're going to be working on upfront, right? That's a little bit different from when you're just getting hired for a full-time position, where they tell you the high-level description of the position, not the job itself. But when you get the job itself, hey, you're going to be building a system with this and such characteristics. The day one approach is thinking, if I get hired, what would I do day one? Okay, so that was the sort of like the mental model for me. What would I do? What questions would I ask? What libraries would I install? How would I prepare my computer to work on this solution? What is the sort of like the structure, the high level, the plan? And I will go and do all of that stuff before applying. So I will do my day one and I will put it, on paper. Like I will create this PDF file with all of the questions, with the high level plan, with the structure, and that would be my application. So now the person who's receiving that is comparing 99% of the people who applied are sending a resume talking about them. I was sending the entire project plan with questions very specific to the project with, hey, I did this and I have these questions and what do you think about going this direction, and my resume. I was talking about the project. Very, very, very easy to get noticed when you do that. Just to give you numbers, because I used to do most of my freelancer in a platform that's called Upwork. I know many, many people working on Upwork. I worked for years there. People that are usually successful with 1% or sub 1% acceptance rate. So from the jobs they apply to the jobs that they get hired, sub 1%, very, very successful. I had 24%. So huge percent. So basically every 4 jobs that I applied, I got called to 1, which is very, very high. And it was because I was doing this thing. So that would be my recommendation to getting hired. Yeah.
Awesome. I appreciate that very much. It's time to wrap up. But this has gone by so quickly, and there's so many, generative ideas, non-LLM generated, which is one of my favorite forms of generation. I'm once again linking to your course in the chat, and because we have a lot of questions still about where can I learn more, and I think this is a perfect place to do so. I'm wondering if you have any other advice for people who want to really become good at machine learning and AI?
Yeah, I mean, the only thing I think this has become the latest advice is when I started in 1994, I started writing code, and I promise you, they told me that that was only for nerds. Computer was just a fad. And then they told me that my job was gonna get outsourced to a place that people were charging $2 an hour for my job. Like, what would you learn to code? You're gonna get replaced by those people. And then they talked about no code and low code, and all of those new ways of building applications are going to take your job. And now they're saying that AI is going to take your job. My advice is do not listen. So in 30 years, if you start right now, in 30 years, you are going to have a job. You're going to be building systems. You're just going to move up in that abstraction layer. Your job in 30 years is going to look very different to what I'm doing today. But just do not get demotivated because some people with financial interest are telling you that code is just going to get replaced by LLM. So just start learning and you're going to have a great career. That would be my advice.
Awesome. And on that note, I'd like to quote you, and to everyone else here. Your pinned tweet, which I love, says, AI will not replace you. A person using AI will. And I think that's a beautiful call to action to encourage everyone to start experimenting and exploring with AI and making it a part of their general toolkit in work and life as well.
Yeah, 100%. Yeah.
Awesome. I'd like to thank you all for joining. We've had nearly 200 people join throughout and expect many more afterwards, which is super fantastic. So thank you all for coming. Most of all, I'd like to thank you, Santiago, for your time, your wisdom, and also good vibes. It's always great to chat with you, and I enjoyed it immensely.
Oh, so thank you. Thank you for inviting me.
Awesome. All right. See you next time, everyone. And scene. Dude.
Cool.
That was a lot of fun.